I am trying to wrap my head around a lot of things right now in regards to category theory and whatnot. Let me, man, like, where do I even begin, bro? Also, a guy will be arriving soon-ish. I mean, like, either in the next 2 minutes or, like, the next hour, so I don't know, 2 hours, but yeah, whatever. Anyway, so I've been looking heavily into a few things, actually. I don't know how much I've talked about this. I mean, my last video wasn't category theory, but that was on the 15th, and that was 2 days ago. In the meantime, I've been working on, I was actually working on making a GUI in IMGUI for this launcher thing, this modding launcher. I'll just show it off quickly to kind of give like a quick recap. Yeah, this. So like, I made this thing, very simple, but like it gives you buttons to launch this modding API thing. So you press launch game and it launches it. You launch vanilla and it launches vanilla game without the API connected. And I'm doing this by this is the original project, and I'm creating I forked it to create a pull request and whatnot to then hook those changes, because right now the API is only terminal only, but the guy wants a GUI for it. I mean, I say the guy, it's my friend Capillarity, and that's what I'm doing. Obviously it looks like absolute ass right now, but as it, right now I'm focusing on functionality before I go on to other things. But yeah, also, but like, it's a Windows app for, like, it's a Windows Steam game that I'm developing in Arch Linux, so like that's a whole other thing that I need to kind of, a bit of a learning curve there. But yeah, you press launch game, launches the game. A lot of things still left to do with it besides just making it look nice, but it took a while to even just get to this point, like to get it working on Linux. So that was cool. And yeah, but anyway, aside from that, also I was recording that, but initially I was trying to do it I think with Qt, and that's when I realized that I didn't have swap partition. Like I had 0 gigabytes allocated to swap partition, and I only have 16 gigabytes of RAM. So what happened was that whenever I tried launching Steam with the game and have OBS open recording and have Discord in the background and then try to launch this thing, it would just crash Steam, and then it would like crash Claude as well, which I was using to help me a bit. So like then only like, I don't know, like a few hours later I realized, oh, I don't have any swap partition allocated. I should probably do that, which led to less crashes. But point was, I had to stop recording just so I could do the thing. And even now, I don't know if I can record and do that at the same time. If I can, I will. If I can't, I'll just leave it and only show the results. But yeah, so that's why I didn't upload yesterday, for instance. Otherwise, I would have. So that's that. Apart from that, though, I've been working more on True. I mean, I say working on, it's theorizing, researching for True, my beautiful programming language. Let's see. This was the 15th of August, right? So 16th of August, I was thinking about getters and setters. Like the whole day, I was thinking like, how could this work, right? Because the idea is like, what is a type? And like I asked in this Discord server, the programming language Discord server. I forgot the full name is, but yeah. Very cool community of programming language designers and whatnot, and enthusiasts. I asked them, what is a type? And there's many different ideas and like interpretations of what a type is. Different languages have different, give types different capabilities. Like in TypeScript, you could argue that a type is just a restriction, right, on what a value can be, whereas in more, I don't know, like atomic composed languages, a type is more like something that you build up, perchance, I don't know. In some languages, types can have methods, right? Whereas in others, they can't. In some languages like C#, you have getters and setters that are literally built into the system, whereas in other languages you don't. You have to make those as manual functions. So, yeah, I was exploring that. But the main idea that like got me interested is that a U32 is basically a morphism, right? When you have a variable, like let's say I've let me just go and come here. Let's say I have a variable x, right? Let's say I have a variable x. And x is a U32, right? Now, if I call x, if I get x for something, like let's say I want to print x, right? Then what I'm actually doing is I am accessing the state. So I'm accessing state, whatever state x is stored in. So like it could be in memory, right? and then in that case it's encoded in bits. So it's getting the bits, it's taking the binary value there. Now in this case it doesn't have to do it in like math because integers are conventional on systems. Yeah, like there's no actual calculation that like turns a bits into like a number. It's just that it's just encoded as it. But either way, it takes that, right? And then there's basically a morphism. The getter is a morphism from the state, the bits, to the value I want. So then I get that, and then that's the value I get. So let's say let's say it's a U8 for simplicity's sake, and the bit pattern is currently stored as 0 0 0 0. Yeah, 0 0 0 0 0 0 1 1. Okay, that's 3. Very, very, very simple. That means that the getter gets those bits, and then there's a morphism from that to 3, right? There's a morphism from 0 0 0 0 0 0 1 1 to 3, and that's what I get, and that's why I see get printed. Okay, sorry, this lighting is not it. Right, so that's a getter, and a setter is, I guess, the opposite, right? For a setter, you pass in the abstract integer, right? So every representation, so 3, and then what that will do is it will modify the state, right, behind the scenes, and then return. It doesn't have to, but it's good to have it return the new value, right? So I would say set x to 3. It would go in. It would change the sorry. Let's say it's 3 already. So let's say I want to set x to 5, right? So it would go in, and it would change the bit pattern to, or set the bit pattern to 0 0 0 0 1 0 1. Yeah, doesn't matter. Which is 5, and then it would return the new value, which is 5, because that's what I gave it, right? And then for setters, there's also like a modifier, right? So like, let's say I want to do x plus equals 3. Then that will modify it and then return the new value. So let's say it was 3 before. I do plus equals 3. So I'm passing a function in this case, which is basically a setter, kind of like I'm passing like some kind of setter function, and then that will which return the new value, which is 6 in this case, because 3 plus 2 is 6, right? And turns out there is actually, okay, so but like in this model, a type is essentially a getter. A type is a collection of 3 morphisms, right? The getter, the setter, and the modifier. Although you could consider the modifier to be part of the setter. So really a getter and a setter, which is interesting. But then you can also extend a type, right? Like you can add other functionality to a type by adding more morphisms. But like the fundamental, the kind of like, yeah, like the base requirements is that it has a getter and a setter. And then anything I add on top of that is extra. Kind of like how in category theory, right? Like there's rules for what like a monoid is, but then I believe you like in terms of like it must have like an identity morphism or something, and like it must have something for something whatever. But like the point is, I believe you can still have extra like additional morphisms on top of that, but it's still a monoid. It's just that you have the core requirements, and then you can add more morphisms on top. So this is like going into category theory. Turns out there is actually a thing for this. At first I was looking into Haskell lens library, and like the whole idea of like optics. So like you have ISO, like isomorphisms, and an isomorphism is basically just a bijection, which means that for every input there are outputs, and then therefore every output also has an input. Now that integer to U32 is not even an isomorphism, because not all of the values are mappable. There is a limit, right? But like I could say that like a U32 is isomorphic to to the range of 0 to 2 to the power of 32 minus 1, right? Type thing. So then I was talking in the SQL Server, and apparently state monads. State monads came up. I've heard of state monads before, but didn't really understand what they meant. But apparently what it means is pretty simple, right? That state I talked about, right? Like the memory that I talked about, that state being passed around, that is the state monad. It's just that in every single, well, pretty much every single programming language, that is implicit, right? When I have, like even in, well, I guess Haskell doesn't really have that, but like even in like C++, for instance, or C, whatever, right? Like if I have int x, then I have x, and like let's say like that's the only variable in my entire program. My state is my state can be thought of like a list or a set of, I don't know, key to value pairs, right? So like x is my key, a map. Let's just say it's a map for now. So x is my key, and then I have my value, which is whatever the representation is in memory. So for a U8, it would be 8 bits, for instance, right? And then so that's my state. So when I do get x, what I'm doing is it's a function from my state to a state and value. But the thing is, the state is passed around constantly, because throughout the entire program, right, I need to pass a state to keep track of it. So for a getter, let's say my state is x with, again, the bit pattern of 3, then I would, when I call get x, it's a function from my state, which is that, to the state again, because I need to still maintain it, right, and pass it around to then compose functions and whatnot. But then I also have a value, right, and my value there would be 3. And then with this, I could have another function. So let's say I get x, which is 3, and then I have my state, and then I want to call set x afterwards, right, to something else. Well, I don't know, whatever. So set x would be, again, it'd be the current state, but then also the new value. So I have set x, which like internally would like access the map and get the value of x and get the bit pattern and like interpret the bit pattern as like an integer. Like that's what's going on inside this function. But the function signature would be the current state, and then the value you want to apply to it, to x, right? And then you get returned the new state, and then optionally the new value if you want to return that. You don't have to return the new value. You could just return the state, but it's quite convenient to have a set statement also return a value. In the same way that like assignment in C++ will return the new assignment, or plus equals will return the new value as well. Not something you use that often, but like it has its uses. So, but like that's just to clarify that is, I believe, optional. But the key point there is that without the state, a setter just looks like I'm gonna pass in a new value and then get that value, right? Whereas with state, it's the same function, but then state is also being passed around with it, you know, as like a tuple. So it's very cool. And then modify x would be the exact same thing as a normal modify, just that the setter now has a state inside it, and then the function in general also has a state in its input and output. And it means that when you compose the functions, you can have some kind of sequential thing going on. Like, what's like an actual example? Like, suppose I have a function print, right, which takes the takes a state, right, but then it also takes a variable reference, which you know, let's call the reference the key of the map. So I pass in the state and then the map key, right? So that's not really good though. Okay, I could do that actually, but let's say instead that my print function takes a value, just an integer value, and then it prints it. Okay, so the internals, whatever, like it prints stuff. Don't worry about that. What matters right now is that it's just the way I compose these. So say I have a print function, again that takes a value, right? So the signature of that function would be, it would take a state, the current state, and it would take a value, and then it would return nothing, right? It would return a unit type. Now, although it doesn't necessarily use a state, first of all, the print function would have to use a state anyway, because that's how it prints. So that's like internal. But it doesn't need to access the state to access any variables. So that's the first thing I'll clarify. But what happens is that I can then compose the getter of x, right? So get with my state this key x, and then return the state again, but with the value as well, right? So then what's this setter function, right? So let me actually just write it out. Hold on. So you know how I mentioned that there's a person coming. The doorbell also doesn't work, so that's awesome. Anyway, yeah, so, like, let's say I have two functions here, so I'm going to use C++ here. Actually, no, I'll use Haskell to kind of show this. I don't know, actually, whatever. So let's say I have a function, right? I have print. So print is, actually, I'm going to use true syntax. Print is a function from state and, so print is a function from a state and some value, which we'll call u32, whatever, to nothing, right? A unit. Although really it would return state, because again, state is passed around as the first thing everywhere. Like just think of it that way. And then I have x, which is simply a variable, right? But then I have get x, or get x, which is a state, that's it, to a, because like we've passed an x, so it resolves that, and then it returns a state again, but then also u32. What happens here? If I compose, so print dot get x, right? If I compose this, what I get is print of get x, right? That's how composition works, which equals, which has the type, whose type, right, is state and u32. No, state to state. Yeah. Because like at that point it's just a function call, and there's no other parameters. Maybe a better example actually is just get then. Okay, so let's have get, and here get takes state and a value. Let's say, just a value type, whatever. Let's not get to. Okay, for some reason I can't copy paste anything. What? Copy. Bro. Okay, Discord's being really funny. So if I compose print and get, right? Then what I get is a function from get input, which is state and value, to the output of print, which is just state. Sorry, get would be, no, not a value, no, it'd be a variable, right? So like a variable key, I'd say. Dude, why is it not working? Holy moly. So then it'd be a state and variable key to state, okay? So there's an example. I know it's not zoomed in like at all. It's probably hard to see. But the idea is, I can compose this now, because then I'm composing. So I'm first calling get, then I'm passing the result of get into print, and it's worked because get takes a state and variable key and returns a state and value. Right. So if we just ignore state here, like it takes a variable key, so x for instance, and then it returns a value. If x is 3, then it returns 3, right? But then just add state there, so it takes a state and variable key and returns a state and value. What does print take? Well, print takes a state and value. So then we take the output of get and pass it as input into print. So then that state and value gets passed into print, state and value, which then just print set and then returns state, right? The new state of the program. Maybe state has to be modified so that state somewhere, I don't know, I have like my terminal output, my console output in the state, and the state has not been modified so that output now contains 3, you know, whatever. But the point is I can compose that. and I now have a way to pass state through functions, but like without having like some external global access. No, like everything that could be input is inputted. So that, I mean, that's how it works. Really, they're extremely simple. For some reason, it just took me a while to like really understand that. And then a setter is similar, right? It would take a state and a variable key, but then also a new value. So it would take a state, variable key, and value, and then it would return the state and the new value, right? And then I can use that to also print, I guess, but whatever. But I kind of wrote it out here, like set is a function taking state, a key x, and then 5, the new value, and then get is just very similar, but just without the new value, because I'm not sending anything, I'm just getting it. So in a sense, a set is kind of like just a more complex get, but like obviously not, because they both do different things under the hood, but like the signatures look quite similar. And like a set effectively ends by calling get as well, so like there is that. Like you could think of set as like having a set function that returns unit, or well, I guess returns state normally, but then composes with get. No, whatever. Like you can think of set as calling get internally. But of course, it can be optimized to instead return what you gave it. Like, the implementation details are kind of whatever. What matters is that the type, so check out here. So what I was thinking then for my language is that every variable, should essentially be, well, no. So, first of all, there are functions, right? Functions are ubiquitous. I don't think you can have a variable, a programming language without some kind of function, because a function is the way you do things, right? The question is, how do you model types and variables? So a variable is an instance of a type, right? It's an object, let's say, and our type is a type. So I'll say type an instance to refer to classes and objects, okay? So x is an instance of an integer, right? And it is stored in our state. So x here, that we write in our program, is really like an ID that is stored in our state. And that's how you'd implement a compiler or interpreter, right? You would have a literal state, maybe like it's a map of like variables to their values, and like that's literally how you would model it. Not that that's necessarily important, but it's just an interesting thing to notice. And then usually languages will hide, like the whole setting, getting, modifying kind of thing, but you could make it explicit, like this. So here, what I have is my integer type comes, well, I say integer type. All types in this language come with 3 functions. Really 2 functions, but you could consider it 3, which are set, get, and modify. Really, get should be first, actually. And I know that in I don't know, state monad theory, whatever, like officially, it's get, put, and modify. But I say get, set, because setters and getters, same thing really. Like it's just different terminology. Also, set and get sound cool together, don't they? So yeah, right. So we don't have to make the state explicit, because state is literally passed around to every single function. So that can be ignored from, or like omitted from a language's syntax, because otherwise it'd be horrifically tedious, and not really give any benefit. Unless you wanted to like share a program's state to a different program, but I don't know why you would do that like that. So again, like think about all of these having like an implicit state parameter as well, connected to every input and output. And then so then every type has at least a set and get and a modify, where set takes a value and then modifies the value and returns a new one. So it modifies the state. Get does not modify the state, so in that sense it's a non-writing function. It only reads, and that's important to like distinguish for concurrency reasons. So set and get, could have different effects that are labeled. So get would just take no input. You just say get x, whatever. You know, you call it on the object, which then passes it, and then you get implicitly, and then you get the value as a getter. And then modifier essentially takes a setter as a function. Yeah, that's just wrong. It essentially takes a setter as a function, and then applies it, and then returns a new value. So like +3 could be a setter for, or like some kind of definition for a setter. But then you have to, obviously, you have to define them, right? So here I use _x to mean, here I have _x to mean the internal representation. These are just like dummy, very default implementations, right? So here this accesses some other variable from the global state, which is accessible through using identifiers like this. So like let's say x is actually pointing to some internal _x, and then it just does that. Yeah, like it's literally the most bare bones thing that it could be. But the idea is that every type has these. Different types can specify different setters, getters, and modifiers as well, explicitly. And that's how like a U32 works. Like a U32 would explicitly be a setter that takes a value, modifies its state, which is the whole bit representation, within its like definition of the set function, and then return the new value. Or for like a getter, it would just take nothing, but you say x.get, whatever, or just call x. It depends how you want the syntax to look. But then that would return, well, it would access the state, interpret those values again within its definition, and then return that interpreted value. And same for modify. So that's how that essentially works. And it's pretty simple. In fact, it's very simple. So then, what I can have is a distinction between abstract types and concrete types. Concrete types... Oh. Never mind, they aren't coming today. So I guess I'm actually free to do whatever I want. Let's go! Hold on. Okay, yeah, so anyway, so the language has a very clear distinction between abstract types and concrete types. A concrete type is one in which the user, right, the programmer in the language, in whatever library, has specified an implementation of the type, or like at least the implementation is tied to the type. Let's say, because like there could be some like built-in implementation still for like U32. I don't know how that would necessarily be modeled within the language itself. It probably could be, but there would need to be some kind of built-in thing somewhere for the compiler to kind of hide away. So a U32 would be a concrete type because like you know for sure that it is implemented as a sequence of bits, and that is what makes the U32 type. If I want to have like trits or like qubits at some point, I would have to make a new type because U32 is specifically for bits, right, and for a sequence of bits, and it has a concrete implementation, and therefore it also has a stable ABI, which is important for many cases. Whereas an abstract type could exist without any implementation. So for an abstract type, it is specifically not tied to any concrete implementation. That means it does not have a stable ABI. It could change arbitrarily. It means that the user can override it, like here. So, which I'll get into a bit. And then when it comes to compile time, right, if the type is not given any override or any concrete implementation, the compiler will simply choose whatever makes the most sense, right? So, for example, let's say I have an integer, right? Let's say I say x is an integer, and the compiler is able to deduce that my integer never exceeds, I don't know, like always stays within the range of 0 to 100, right? Like let's say I have an age, and somewhere I say, I inform the compiler, and other users. By the way, this doesn't ever exceed 100, so don't worry about it if it's higher than that, right? So then the compiler will take that information, probably make you handle it in some kind of way. So like, what if it gets violated? Like you have to make it explicit, or have like a promise keyword. But then if that's violated, then it just crashes. So whatever system is there for safety. But the main idea is then the compiler can use that information to say, okay, then for this instance, then this variable x, which I know that is always between 0 and 100, will just be implemented as a an unsigned 8-bit integer, because that may be the most efficient. Or maybe on a different system, maybe a U32 is more efficient, because U32s are more efficient to read and write to, and this particular variable is read and written to very frequently. Or perhaps a U7 works, because then it's only 7 bits, and like I want to be very conservative. Like, whatever the case, the compiler will choose it based on the compiler's own internal optimizations, right? Which is pretty cool. And it allows for flexibility there. The downside is that, again, there's no stable ABI. But then to give it a stable ABI, all you'd have to do is define the getters and setters for that type. Well, getter and setter. Not even for the type, but for that particular instance of the type, for x. Like, maybe I want to assert that x is actually like, it says integer on the surface, but it's actually a U8 under the hood, like whatever. The issue there then is that the type cannot be integer. Like, the type would still have to be isomorphic. So you would not be able to say that x, like, the compiler can say that x is an integer, because as far as you're concerned, it's an integer that just happens to stay within the range of 0 to 100, right? So like, that's an optimization. And you could argue that that's not good. Like, maybe you should explicitly just say that this is x, which is a 0 to 100 type, rather than the integer type. And I suppose I could explore that, but whatever the case, I can override the getters and setters to have my own implementation. So what happens then is, if I have a class or a type with public fields, then those fields could just be the variable, right? Or I could specify a getter and setter in the same way that I would for C#, right? Because like, all the getters and setters are functions that I can override to do whatever I want. Yeah. So there you go. There's the getter and setter. So a type. So every type, therefore, and every instance comes with the functions get and set. That means when I declare a type or a class or a struct, what have you, there are the functions get and set that I can override. If I do not override them, the compiler will either deduce from the well, I guess the context. Like, let's say I have a type that is a U32x and a U32y. So it's a vector, basically, or like a 2D vector with, I mean, not like in the mathematical sense of like a vector with like an x and a y, right? Coordinates, whatever. Because those are both U32 fields, the default getter and setter would literally just be like, it would just return a product type of x and y, which are U32s. And like, that's just whatever. And like, the setter would take an x and a y and then apply that. Whereas if I override the getter and setter, maybe I want to change the interface. Maybe it takes strings for its interface and then returns, and then for the, yeah, maybe it takes and returns strings, and then that's the getter and setter, whatever. And then maybe you could have overloads for the getter and setter, but I'm not so sure about that. Would probably only do that through traits or something like that, or like type classes. So that's also just to be explored. But that's for like the type level. So like in C++, like if I want to have that kind of functionality, so like, let's say I want to be able to add two vectors together, right? In C++, I can't really do that without overloading the operator plus and the operator plus equals right? And other things too, like operator minus and minus equals. Like I have to explicitly do that. Whereas in this case, in this case, the default, as long as I define the addable trait, then that would work. But even then, like, could it be automatic? Like, just like have like a well-defined thing for like adding? Maybe not. Whatever. Okay, never mind. That's irrelevant. Really, it's just the getters and setters, right? Hey, and I can overload them. Like, suppose I have like a health variable, because like the cool thing about getters and setters is that they allow you to change the implementation without changing the public facing API. So that's for me to kind of figure out and play around with, but that's what I have been doing. Anyway, now this takes me to my next thing, which is concurrency, right? How do you model concurrent programming? Because the whole state monad system only really works for sequential operations, right? Like I pass in the state, I get the state back, and then I pass in the state, that result to something else, which returns that, which is that. But what if I need to pass in the state to two different things at once? But then like modify the state in both kind of things, right? Like it works for parallel computations, which are not happening it works for single-threaded parallel computations where really you're just rapidly task switching, and that works with the state monad, but then also with the continuation monad. So like monad, for the record, monad just pretty much means like I'm passing it as like a product type and I'm passing things together. That's what I take it to mean. So a continuation, think of a continuation as like a state for a function, so that when I come back to that, I can then just continue from that state, or from that continuation, whatever, execution, whatever, and then I'm just task switching, right? And that works. But then what if I have true concurrency? Like what if I have true multi-core concurrency where things are literally happening at the exact same time? I don't know how that would be modeled. But apparently there's this thing called so first of all, in category theory there are monological categories, which is something that I think I'll learn in this book I'm reading, The Category Theory for Programmers. The Category Theory for Programmers, Jesus Christ. And there's also symmetric monological categories. Symmetric monological categories apparently have a way to express operations that can be computed in parallel, but like truly in parallel, like multi-core at the same time. Which is what you would expect. So like I asked this question because I was curious: is there a connection between synchronous and asynchronous execution, and some such product types? And it turns out yes, there is. Right? You can represent an async operation or operations as like a product kind of type. Although I believe it's like a tensor product, whatever that means. Tensor product, and they're like some kind of like associativity or commutativity laws and whatnot. I don't really understand it, and I want to read more deeply into it. But the point is there is a way to represent concurrency, and it's so useful that it's literally used in quantum computing, which is kind of crazy. So then there are these resources that I got Claude to recommend to me. So like there's categorical quantum mechanics, literally picturing quantum processes, right? Physics, topology, logic, and computation, right? So these two books in particular, I think, were recommended from Claude. It said Bayes, Mastey, and then Koek and Kissinger. These two books in particular, which I do want to look at. There's also another way to do it, which is to represent concurrency, which is through process calculi, but I understand even less about that. All I know is that right now I'm learning about category theory, and so the category theory approach is what kind of sticks out to me. Yeah. So that's my next steps, pretty much. This guy said, so SMCs, which are symmetric monological categories, have a lot of utility for language semantics in general. You then add a ton of structure on top of them to get semantics for quantum languages specifically, which is very, very interesting. This guy said, I sort of like thinking of monological categories in terms of wiring diagrams. The fundamental kinds of composition you can do in wire diagrams are exactly what you can get in a monodal category. And then some additional structure can correspond to being able to do additional things in those diagrams. For example, if it is symmetric, then you're allowed to have wires cross over each other. This is not, in general, allowed in arbitrary monodal categories. Right. Because, like, symmetry exists in maths, right? So, like, you would expect there to be some kind of way to represent concurrency. A symmetric monodal category is, like, the minimum that you need to have. Yeah, I think. In order to have it to describe something that, like a linear type system, since you cannot, in general, have two wires coming from the same output, and every output must have a wire. Right. Yeah, so, like, this is something to read into. Because, like, really, like, I have these ideas, but I'm just missing the theory to back them up. And, like, I don't have the prerequisite knowledge. So that's what I want to build up by reading Category Theory for Programmers. So here it is here. Here's the book. In the last video recording, I believe I read chapters 2 and 3. So there we covered, or I covered, let me open Obsidian. Nice. So there I covered, can I get a table of contents actually? I think it's just too small. Okay. Yeah, so we covered types and functions. I had a bit about like what are types, right? Which didn't really go into like as much depth as like what I was like asking, like what is a type really? But there's one idea of types is just sets, right? Just a collection of values. That's a type, or like valid values. We covered the bottom value, which is a function which may not return. So that's cool. There's a way to represent that. And then if they return a bottom, then they're partial, right? There's some inputs which don't have outputs. Not even like for like asynchronous programming in general, but like just for functions which like literally can just fail. I don't know how you handle partial functions though. That I don't know, and so we'll see if that gets elaborated on. Yeah, I have some thoughts about this here. And then there's chapter 3, which we're for about categories. And so like we like the zero category, the free monads was something, some orders here. Monoid as a set, which is different from monoid as a category. So like there's the category monad. Sorry, there's a categorical monoid, but there's also the monoidal category, and they're different. So yeah. So next up is whatever Kleisli categories are. So we'll look into that. Yeah. Anyway, by the way, here's another book that it's the book. One of the books I talked about. Someone recommended it officially, so there you go. I can read that at some point. Anywho, so I don't know what Kleisli is, but I literally just heard about it just now, because I was yapping to Claude about this kind of thing, so I get a better idea of what I actually need to research. And it mentioned Kleisli types or whatever somewhere. Just give me a second here. Kleisli composition, right? So it's under the monoidal symmetric monodal categories. Okay, so monoidal or symmetric monoidal categories. Proper concurrency wants two composition operators sequential, like Kleisli composition, whatever that is, and parallel tensor product. I don't know what either of those are. I've heard of tensor product, but yeah, I don't know what it is. A monad only ever gives you the first, which is sequential. Process calculi are built on categories with genuine tensor products for this reason. Yeah. So I don't know like if process calculi is like the next step after learning about symmetric monodal categories, but anyway, interesting that literally the next chapter here is called Kleisli Categories. So I can find out more about that. Yeah, so let's get back into this the flow of things here. Changing a read-only file. What do you mean? So let me go ahead and first of all add this to this header. Jesus Christ, where am I thinking then? Well, I still haven't gotten used to my own keybinds, which is kind of problematic. Like read only, add this to override. Okay. What's it read only? I guess like I loaded it badly. Like I have Windows N to switch to my notes, Windows 1 to switch to this, right, because this is my thing. Windows N for notes, M for Discord, L for Claude, and B for browser. But like switching between these sometimes can get me muddled. Yeah, I'm not sure what to do about that, to be honest. Like, I could instead have like Windows S to switch, and then like it will show my different things. So then like rather than like memorizing my own like what belongs to what, which like it sounds easy, right? But like it's just hard to do it like in the moment, you know. Whereas if I just have like a Windows S that shows everything, and then I press like a key to switch to a certain tab, then I don't have to think about like, okay, which one is it again? Like I just do it. I see which one to go to. It's like that. I mean, it'd be similar to see, like right now, like Jesus Christ, like it'd be similar. Like let's say right now, like a NeoVim, right? Let's say I want to go here, where my mouse is on this true here, right? I can press S, my target, so Shift T, and it will show me a bunch of different keys to press to go to different parts. So then I can see, well, there's Q, press Q, now I'm there, right? Or let's say I want to go back to the K in Kleisli Categories, SK, works for both lowercase and uppercase, in this case, press J, and I'm there, right? But like I don't have to think about what to press. I just think about, okay, I see where I want to go to, so I press S, T to go there, and then I can press a button and to go there, right? In this case, it'd be even simpler, because like I just do Windows S, and then it would just show all my windows, and then I just switch to the one I want. Especially because like right now this is like first of all, these sequential ones, like 1, 2, 3, 4, 5, like these are purely arbitrary, you know. So like it being like here in 1, like this PDF being in 1, like I have to relearn that every time I do it, because it could be in a different workspace depending on what I'm doing. Like maybe it's on 3, you know, so now I have to switching that in 3 instead of that in 1, you know, which is a bit confusing. You know, and like even like these ones don't change, but like for some reason like it's just hard to remember which is which. I don't know if I can get used to it, or if I should go for a different approach. Anyway, see what I mean? Okay, I'm looking for L, right? like I know what I'm looking for visually, but I can't remember like what it belongs to. Like even though M is for notes, when I want to go to NeoVim to edit my notes, I don't think I'm gonna go to my notes workspace. I just think, let me go to NeoVim, you know? Or like when I want to go to Claude, I don't think, let me go to my LVM workspace. I just think, open Claude, you know? Not open Claw. Yeah, it's interesting. If anyone here uses Arch Linux and like has workflow things, let me know. Anyway, so he talks about it. Yeah, Claude is a male in my eyes. That's here. So, interestingly, I've recently heard about Kleisli via Kleisli Composition. Interested to then learn more about this. Now, is this not useful? Maybe not, but it's just so that in the future when I come back to this, I can look at it and say, oh yeah, that was a thing. Kleisli Composition in monoidal categories. When researching about how to model concurrency. Yeah, that's a bit more detail there. It's kind of important. See, my instinct there was to go to browser, because usually when when I'm reading something, it's in my browser, right? But no, in this case it's 1, because in this case it just happens to be here. You've seen how to model types and pure functions as a category. What is going on with the highlighting here? Bro, it's actually highlighting both at once somehow. freaky as. Like, get me a proper, like, a good PDF editor, please. Or I will make one somehow. You've seen how to model types and pure functions as a category. I also mentioned that there is a way to model side effects or non-pure functions in category theory. Right. Did he? I can't remember at this point, honestly. I just remember that there's a way to model side effects or non-pure functions. I guess they probably did. They showed us how to model bottoms, right, which is a funny name, but it's functions that may not return, partial functions, there you go. So let's have a look at one such example, functions that log or trace their execution. Something that in an imperative language will likely be implemented by mutating some global state. Global state. Is this literally going to go into state monads? There's no way. Because I spent a decent amount of time researching state monads, because I wasn't sure when it would come up in this book. Interestingly, this has no subchapters. It does, okay. This is like the header, okay. So the funny thing about side effects is, right, it's only a side effect if you're not passing the state, you know? Like, there's a global state, but you could just pass in the global state as non-global, right? Like pass the global state in a function, and suddenly it's no longer global, it's just local. And, like, therefore, any changes to that state is well documented. So it's no longer a side effect, you know? So let me... L. No, it was N. Like, why do I think it was L? What the hell? Let's have that as a quote. Paste that. Boom, 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 boom. That's fine, actually. That is annoying. Yeah, so what I'm wondering is, at what point is global state no longer global? And thus, at what point are side effects no longer side effects? If I'm passing the state, the global state, to my functions, yeah, explicitly. Does this change the way, or can this change the way, in which I think about side effects? Because I really, like, side effects are just caused by syntactic sugar for passing around the global state. Is it that side effects are just the product of having syntactic sugar in a language for, like, implicitly passing around global state? I don't know. Right, let me also move my fat-ass camera here. It is covering some stuff, but that's kind of unavoidable, unfortunately. And... one. God, like, I have to stop and think, dude. Let me just press the button and see what I want. Because, like, again, visually it works. Visually I know what I want. I gotta write this down somewhere, because I will forget. Take me to... ideas? I don't know which one we'll have here. Arch T's are difficult, yeah. Arch to do, there we go. I still haven't done any of these. I need to go through these, like, big time. I got a lock screen, though. That's cool. Literally nothing else, though, is sorted. New way to switch between workspaces. Have a keybind, like super S, that, or super S, lowercase, that, well, nah, sorry, don't worry. That shows all workspaces visually, like you can on Windows/Mac OS, I guess. And then allows you to either click on the workspace you want, or click a key that shows up next to that click, or press a key. That shows up. That shows up next to the window. This way, I don't have to memorize keybinds for switching between targets, but can just choose based on what I see. Type of shit. Alright. Back. Okay, so also, like, for any of them, never mind, whatever. Right. So we got string logger, bool negate, logger, exactly, yeah. You know that this is not a pure function because its memorized version would fail to produce a log. This function has side effects. Its memorized version would fail to produce a log. Ah. Okay. So that's how it wants to think about it. If you cannot memorize it, it has side effects. Because you memorize based on inputs, right? The thing is though, like, in the same way that in like OOP, you can think of it passing an implicit this, or an explicit self, like in Rust. You could think about this also just being an implicit, like, global this, you know? Which is interesting. But that'll be a pointer and not like a copy, right? Which is, I guess, the other thing. Like, when you pass a pointer to a state, the value of that pointer could be the same. It's the content that matters. But you don't want to copy things, right? Does that make sense? But, like, passing by reference, though, like, it isn't really, like a pointer. Like, just think of a pointer as, like, still passing the thing, but just, like, in a way that isn't computationally expensive, you know? But sure, it has side effects. So let me copy this. And put that here. But how do I misspell that, like, every time? This function has side effects. That was in italics. It would be nice if it copied the formatting automatically, but, well, alas. There actually might be a way to do that, if you like a plugin or something. In near them, I don't know. I think you can in Obsidian. Let me just confirm that, actually. If I were to have done that here instead. Nope. Okay, maybe it depends on the on what you're importing from. By this definition, a function only has side effects if it modifies things that aren't explicitly passed as arguments. I believe in modern programming we try to stay away from global mutation as state as much as possible. Global mutable state as much as possible, if only because of the complications of concurrency. And you would never put code like this in a library. Fortunately for us, it's possible to make this function pure. You just have to pass the log explicitly, in and out. Yeah. Oh. Okay. Let's do that by adding a string argument and pairing regular output with a string that contains the updated log. Yeah. This function is pure. Okay. Awesome. Asked and answered. So, the reason I ask questions and note down the questions, even though they could literally be answered in like the next paragraph, is it's good to check your thinking, and it's good to think in general, because it shows you're actually engaging with it. Like, whenever I have a moment where like I have a question and I guess the answer, right? And like, okay, this is probably how this works. And then like even though it can be seen as wasting time, it's still like when that happens, where it answers my questions shortly after, I consider that to be an achievement, because it's like well, because like you've come to the conclusion yourself, you know, which is good. It shows that you have a strong understanding already. Let's do this by adding a string argument and pairing regular output with the string that contains the updated log. This function is pure. It's also, by the way, a sign of a good teacher in some cases, because it shows like they're leading you on towards the result yourself. Although the student also plays a role there. This is literally, by the way, this is literally a state monad. Like, this is what I mean. Granted, C++ does make it so easy to like return multiple arguments, but like you have a tuple with a bool and a string, and that string is the state being appended in and out. Notice how I said, yeah, here, in and out. It's kind of cool. This function is pure, it has no side effects, it returns the same pair every time. It's called with the same arguments, and it can be memorized if necessary. However, considering the cumulative nature of the log, you'd have to memorize all possible histories that can lead to a given call. There'd be a separate memory entry for negate and negate. Yeah. So, what does bool do? Not so. Okay, and so on. It's also not a very good interface for a library function. The callers are free to ignore the string in the return type, so that's not a huge burden, but they are forced to pass the string as input, which might be inconvenient. Is there a way to do the same thing less intrusively? Is there a way to separate concerns? In the simple example, the main purpose of the function negate is to turn one boolean into another. The logging is secondary. Granted, the message that is logged is specific to the function, but the task of aggregating the messages into one continuous log is a separate concern. We still want the function to produce a string, but we'd like to unburden it from producing a log. So here's the compromise solution. The idea is that the log will be aggregated between function calls. To see how this can be done, let's switch to a slightly more realistic example. Hold on. Okay. Let's switch to a slightly, okay. We have one function from string to string that turns lowercase characters to uppercase. Yep. Oh, what the hell? What, is this C? Int? That's a function pointer, right? Yeah. Okay. Transform, begin, and back insert to a result. I assume this is like with, yeah, using namespace standard. And another that splits a string into a vector of strings, breaking it on white space boundaries. Man, function pointer syntax is so weird. Breaking it on white space boundaries. The actual work is done in the auxiliary function words. Sure? I don't know why then it even exists in the first place, but... Okay. Okay. We want to modify the functions to output into words so that they piggyback a message string on top of their regular return values. With the pigs. We will embellish the return values of these functions. Every chapter, bro. Embellish. Embellish is a verb that means to make something more attractive or interesting by adding extra details, decorative features, or sometimes untrue statements. It comes from the Latin word bellus, meaning beautiful. Okay. I did not really know that. Also, I realize I'm not even, like, taking notes on this anymore. Maybe it is actually easier to just take notes directly into Obsidian, rather than, like, highlighting things. because like I don't look back on the highlights anyway. I only look at the Obsidian notes. So there's not much point in me doing the former. I only did it initially because I thought like it would save me going back and forth, but it doesn't even matter, does it? Like this forces me to actually like process what I'm thinking, as opposed to just like highlighting something and then like coming back to it later. Because God knows that's not guaranteed. Embellish. So embellish is to what? Is to make something more attractive and just adding extra details. To make something more attractive or interesting by adding extra details. I mean, I just want to copy the definition. By adding, yeah, extra details and decoration, even if untrue. And why is it in quotes here as well? Let's do it in a generic way by defining a template writer that encapsulates a pair whose first component is a value of arbitrary type A, and the second component is a string. Okay. Here are the embellished functions. Okay. I'm sorry, why is it embellished? So we have a writer string. What was it before? Yeah, so before it was just string. Now it's a writer string. What's the result here? String. To upper. Okay, so like we're just tagging the... Yeah. We want to compose these two functions into another embellished function that uppercases a string and splits it into words, all the while producing a log of those actions. Here are how we might do it. Yeah. So like this is literally function composition, right? We do P1, and then we feed, we do to upper, and then we feed the result of that into P2. Yeah, we have a common goal. The aggregation of the log is no longer the concern of the individual functions. They produce their own messages, which are then externally concatenated into a larger log. Now imagine a whole program written in this style. It's a nightmare of repetitive, error-prone code, but we are programmers. We know how to deal with repetitive code. We abstract it. Yeah. Usually, when I think of abstraction, it's about reducing repetitive, boilerplatey code.